Hi everyone, today we're going to talk about defining double bond geometry using the CIP rules. So remember, CIP rules, we're going to be looking at something with a higher atomic number would have a higher priority versus something with a lower atomic number. Also, if you have a large carbon chain, you're going to work down that carbon chain and find that tiebreaker, which will help you prioritize the substituents. So when we're looking at a double bond, we are going to prioritize the substituents that are coming off of one carbon at a time. So if we look at something like this, we would look at this as carbon 1, this is carbon 2. So looking at the substituents coming off of carbon 1 versus the substituents that are coming off of carbon 2. So again, we would prioritize this substituent versus this substituent, and we would prioritize this substituent versus this substituent here. So if the number one substituents, so the highest priority substituents, are on opposite sides, so they're going to be trans to each other, this is going to be an E configuration. If the number one substituents are on the same side, so these are going to be considered cis to each other, this is going to be Z configuration. So let's look at some examples of these different types of configurations. So we're going to first look at the geometric isomers of 2-butene. So if we look at this isomer here, so looking at this carbon here first, we have this substituent here and this substituent here. So our methyl is going to have a higher priority compared to our hydrogen. If we look at this carbon here, we have this substituent here versus this substituent here. Again, this methyl here is going to have a higher priority than our hydrogen. So our higher priorities, our number ones, are on opposite sides. So these are going to be trans to each other, or you can call it the E configuration. So this would be E2-butene, or again, it could be also called trans to butene. If we look at this isomer of 2-butene, so again, we're going to be looking at this carbon here. We have this substituent here, this substituent here. So again, methyl's higher priority versus hydrogen. Looking at this carbon here, we have this substituent here, this substituent here. Again, methyl is higher priority than our hydrogen. So now they're on the same side, our highest priority. So this is going to be, they're cis to each other. Or we can call this Z2-butene, or again, it could be called cis-2-butene. All right, let's look at another example. So if we have something that looks like this, so again, we have this carbon right here that we're looking at and this carbon right here. So if we look at this chain versus this hydrogen, so this chain is going to have higher priority versus our hydrogen when we're looking at this carbon. When we look at this carbon right here, we have a fluorine, which is going to have higher priority than this CH2CH3 group. So these are going to be on the same side, the higher substituents. So they are cis to each other, or this would be the Z configuration. So if we look at something like this here, so again, we're looking at our double bond, the carbons in the double bond. So if we look at this carbon first, we have this CH2CH3 versus a hydrogen. So carbon has a higher priority when compared to hydrogen, so that CH2CH3 group would be listed as number one. Looking at this carbon here, again, this is going to have a higher priority when comparing it to hydrogen. So these are on opposite sides, the higher priority. So they are going to be called, they're trans to each other, or we can call this the E configuration. So the third example we're going to look at diene. So what a diene is it's two alkenes. So if we look at something that looks like this. So pH is a phenyl. It's going to look like this, and this is, it just means it's attached to the chain right here. So let's look at this carbon here versus this carbon here. So looking at this carbon first, we have this phenyl and this hydrogen. So the phenyl is going to take higher priority because it's a carbon versus a hydrogen. When we look at this carbon here, same idea. We have a carbon that's attached to an oxygen here. So this would be a higher priority in comparison to hydrogen. So the higher priorities are on opposite sides. So this would be an E configuration here at that double bond. Now we can look at this carbon here versus this carbon here. So, I'm sorry, this should be a CH3 group. So when we're looking at this carbon here, we have this methyl group is going to be a higher priority when compared to our hydrogen. And then when we're looking at this carbon here, so what's going to happen is this substituent here would actually be a higher priority because we have a carbon attached to an oxygen versus this chain up here is going to be a carbon-carbon. So what we would do is we would list this one as number 1 here, and then our number 2 would be up here. So they're on opposite sides. This would be an E configuration. So that's actually going to be what we're going to cover today. So this is the end of looking at the CIP rules. So make sure you get a lot of practice on the R and S configurations and then the E and Z configurations for the double bonds. And if you have any questions, don't hesitate to reach out to me. Have a great day, guys.